And then now let's take a look at our problems. All right, range rule of thumb. How about someone read? Brandon, go ahead and read. Are you chewing? We can get Gina to read. Gina, read.
Range rule of thumb for interpreting a known value is that we read. Informally define usual values in a data set to be those that are typical and not too extreme. Find rough estimates of the minimum and maximum usual sample values that follow. Minimum usual value mean minus 2 times standard deviation. Maximum usual value mean plus 2 times standard deviation.
Right. So again, when you see the words range rule of thumb, then that means that's that whole thing where you have your mean, and if you go 2 standard deviations this way and 2 standard deviations that way, these are where your usual values fall. So this is the minimum usual value, and this is the maximum usual value. So that kind of occurs, and that's true for very, very many data sets, and most of the ones we're going to be working with. So here's your quiz problem. The key is, when you read this, first of all, get used to reading and cluing into the verbal cues. When it says, had a mean of, that's your mean. When it says, had a standard deviation of, that's your standard deviation of. When it says, has a sample of, what's that? That's your sample. And when it says, has a sample of 20 math textbooks, what's the 20?
That's your value, variable.
That's my n. That's my sample size. So sample of is my sample size. So a lot of people want to grab that and make that into their mean or their standard deviation or something else. So that's your sample of, that's your sample size. So this here is my x bar. This here is my s, and this guy is my n. Good? All right, so here, there's a couple different ways you can do it. The other clue is, heads up, when I say range rule of thumb, that's when you know, oh, range rule of thumb, that's take the mean and you go 2 this way and 2 that way, and you find those usual values. So that's your clue, verbal clue to do this. So we're going to find 2 standard deviations. That's one way. So the first way is to find 2 standard deviations. So that's 2 times 41.1, which is 82.2. And then add them and subtract them from the x bar. So x bar minus 2SD. So that would be 678.4 minus 82.2, which is, help me out, 590 what? 6.2. That's my minimum usual value.
Yes.
And then we have our maximum usual value, which is x bar plus 2 standard deviations,
So 678.4
which is
plus 2 times 41.1 was 760.6.
760.6. Great. Perfect. The other way you could do it is you could draw our little picture, right, with the 678.4, and then jump 2 this way, right? Plus 41.1, plus 41.1, and you'd end up at 760.6, and you can go backwards, right? Minus 41.1, minus 41.1, and you'd end up at 596.2. So these are our min and max usual values. Would a book with 620 pages be unusual? No, it's right in that range. So no, it's in the range. Okay. Coefficient of variation. Rizzo, go ahead and read.
The coefficient of variation for a set of non-negative sample or population data expressed as a percent describes the standard deviation relative to the mean.
Right? So how does it relate to the mean? So you find your standard deviation and figure out what percentage of the whole it is. right? So your standard deviation divided by x bar, because x bar is the average amount in a whole amount. So your standard deviation divided by x bar, and change it to a percent. Imagine you guys have gotten this far, right? So here, what are all these things? Sample of 36 people. What's 36?
The sample n.
That's my n. So get used to kind of sorting out what these numbers are. Mean height of 65 inches. What's 65? That's my x bar. Right, with a variance of 16 inches squared. So this is my what?
Standard deviation squared.
My s squared, my s squared by variance. And then we have a standard deviation of 4 inches. What's 4 inches?
Standard deviation.
That's my s. So you'll notice, almost all the time, we're going to be using standard deviation and mean. And you'll notice, those are the two things that are in the same units. So 4 inches, 65 inches. This one's weird. It's inches squared. It's something different. Right? So the variance we don't use that often. It's the squared one because it has the, it has the inches squared or the whatever is squared. The units are squared. So we care mostly about the standard deviation. S, our critical value. No, sorry, our critical value. Our coefficient of variation is S over x bar times 100%. So it's going to be 4 over 65 times 100%. And you guys ended up with 6.2? 6.2%. Good? Reasonable? Okay. Chebyshevs. You guys remember Chebyshevs from last class?
Yeah.
He was a really great one where it's really cool because you don't need, your data doesn't need to be normal for this. It can be any distribution you want, and it still works. The deal, though, is that it's really, really, all it does is give you a minimum, right? So here, it says at least 75% is within 2 standard deviations, because if you go 2 standard deviations, if you have 2 for your standard deviations, then 1 minus 1 over 2 squared, which is 1 minus 1/4, 3/4, or 75%, will fall within 2 standard deviations. It says if you go 3 standard deviations, then it'd be 1 minus 1 over 3 squared, which would be 1 minus 1/9, or roughly 89%, 88.89%, will fall within 2 standard deviations, at least. Could be more. Usually is more. Usually it's a lot more, but at least. So 75% to 100% will fall within 2 standard deviations. 89% to 100% will fall within 3 standard deviations. So Chebyshevs, again, it just gives the minimum. So in this problem, please change this. This is wrong. This should have been B. Under B, please add in at least 75%. That is a giant error on my part. At least 75% of light bulbs lie within blank. What percentage of light bulbs lie within 3 standard deviations of the mean? Yeah, 89, at least 89. So add in there also, at least 89%. Or you could say 89% to 100%. That works as well. 89 to 100%. 89% to 100%. And then at least 75% lie within how many standard deviations? 2. Which means from what to what?
300 to 900.
Yep, 300 to 900. Because 1 standard deviation is 150, 2 standard deviations would be 300. It's the empirical rule. Brendan, go ahead.
For data sets have a distribution that is normal or approximately bell-shaped, we can do better than Chevy Chevs. About 68% of all values within one standard deviation, and about 95% of all values fall within two standard deviations, and about 99.7% of values fall within three standard deviations.
Great. So yeah, so that's the deal. Here's the condition. It has to be normally distributed. But if it's normally distributed, then we can do better than Chevy Chevs. Chevy Chev says two standard deviations between 75% and 100%. Empirical rule says right around 95%. That's a lot more accurate than between 75% and 100%. Chevy Chev says that for three standard deviations, at least 89%. So 89% to 100%. Empirical rule says right around 99.7%. It's a lot more, gives you a lot smaller range, right? It's right around here. Though again, the restriction is it has to be normally distributed. It also talks about one standard deviation, about 68% will fall within one standard deviation. So you guys need to use this. Does anybody need another minute to finish up the problem using this information for your quiz? Who's finished this? Who's finished quiz problem 4? Who has finished it? Okay, so we need another, take 30 seconds and finish it. Here's the picture of it.
This one here. I'm not saying
All right, so let's take a look at it. It says has a mean of 165, standard deviation of 6. So if you kind of draw the pictures in, it should be like that. Right? If you go out a little bit further, it should be like this. If you go out a little bit further, it would be like this. So between 159 and 171, that's how many standard deviations? 1, so 68%. Yes? And then 153 to 177, that's how many standard deviations? 2, so that should be 95%. Good. So this is, what you got? I can't remember what you guys have. 159 and 171, and 177 and 153. There is a homework problem that you have, which looks kind of like, it's kind of a pain. It's like this. I'll talk about the basic here. So, what percent, okay, so this is my 165, this is my 159, this is my 171. We know, we just talked about the fact that 68% lie between those two. Right, everybody's on board with that part? So, but here's a question. What percent lies above 171 over here? So you're going to get a question similar to that on your homework. How do you find it? If 68% is on the inside, what percent's on the outside? 32. Because it better add up to 100%. Is everybody with me on that part? So if 68's on the inside, 32 better be, these two guys added together better give me 32%. The thing that's nice about normal distributions is that they are symmetric, which means that this amount should be the same as that amount. So it means that this 32%, half should be here, half should be there. How much should be over here then? 16. Should be 32% divided by 2. 16% in each side. Make sense? You guys good? Good to go with this? When you get on your homework, something similar to that in your homework? Same idea. If it's 2 standard deviations, then it'd be 95% of the inside. What's on the outside? Total on the outside would be 5, and then on each of those would be 2.5 here, 2.5 there. Okay. Good. So now we're going to move on to 3.4, measure the relative standing. Z-scores and percentiles we covered last time. So first, take 15 seconds with your neighbors and remember what the population mean, standard deviation, and sample mean, sample standard deviation symbols are. Go ahead. All right, so what's the symbol for the population mean? Mu. Just like the Pokemon. Mu. What about the population standard deviation? Population standard deviation. Sigma. It's the circle with the tail. Yeah, the O with the tail. All right, remember, the population ones are always going to be Greek letters. Greek letters over here. Are these statistics or parameters? Parameters, because they're for a population. Good. Now, how about my sample? What's the sample mean symbol? X bar. Sample standard deviation? S. Awesome. Are these statistics or parameters? Statistics, because they are for a sample. Are you feeling okay with this? So if I take a sample of 42 students, the heights of 42 students, their average is going to be what? A parameter or a statistic? Statistic. If I compare that to the average height of all students, that average height of all students would be a what? A parameter. That would be mu. My sample average would be X bar. Okay. People get confused about that, so I want to talk about that a little bit. Are pink and purple too similar? They are, aren't they? I should not use those two colors. Okay. Z-values. So a Z-value or Z-score is where you find out how far, you have a value that you're interested in. You figure out how far it is from the mean. If it's above the mean, it's positive. If it's below the mean, it's negative. And then you take that difference and you divide by a standard deviation to figure out how many standard deviations it is. Because the Z-score represents the number of standard deviations a value is above or below the mean. I need you guys to all say this with me, not the last line, but the first 2 lines. Ready? 1, 2, 3.
The Z-score represents the number of standard deviations of values above or below the mean.
Good. You need to know this. It's really important. It comes up in chapter 3, chapter 6, 7, 8, and 9. It's all over the place for the rest of the semester. So you really need to know this. It's a measure of how many standard deviations you are from the mean. Yeah?
Apologies, are we still going over the quiz, just so he's on problem 5? I had a question on that real quick.
Yep. We're going to get to it.
Okay.
It's coming up. Question 5 is, this leads up to question 5. So, how to find the Z-value or the Z-score? You take the value, subtract the mean, and you divide by standard deviation. For a sample, it would be x minus x bar over s. A lot of times, people wig out with z-scores and the idea of a standard deviation because they can't really see it or visualize it or wrap their head around it. So I'm trying to relate to something that you guys are all familiar with, which is car lengths, right? Whenever you learn, whoever when they learn to drive heard the thing of like, you must stay 3 car lengths behind the, behind the car in front of you, right? I'm sure that. So you guys, you got used to this idea of a car length and how much that is. So if you kind of think of it as standard deviations in that same sort of way, you kind of think of how many car lengths are you away from the mean. So this guy, he's 1.72 car lengths in front of that mean. So his z-score would be 1.72. So I think that kind of helps some people sometimes to kind of wrap their head around the idea of a standard deviation and counting standard deviations, if you think of it counting car lengths. Remember, every problem is different. So every problem is going to have a different standard deviation. Some are going to be really big. Some will be really small, right? It kind of depends upon your problem. Where your data is really spread out, they'll have a really big standard deviation. If your data is all kind of squished together, they'll have a small standard deviation. So kind of keep that in mind. So this leads to your quiz problem number 5. And you guys need just a minute to go through those and figure out how to calculate the z-scores of these two things.
Sure.
So here's some things to look at. So what are the things that you care about? You care about this guy, that's your score, right?
The mean.
But you also have to find, the mean of psychology and the standard deviation of psychology. So psychology, score of 81 on a psychology test. Psychology tests have a mean of 89, standard deviation of 6. So those are the ones you need for that one. So I'll give you guys a minute to finish those up.